In this video, we're going to go over how you access your online labs. Now, right now, I'm in our Blackboard site, and I'm going to click on course content here. And you want to click on this link, Online Lab Simulations. And you're taken to our online lab course. Now, I'm already signed in. So when you first click on this, it might look a little different, where on the left side of the page, you will have to sign in. And if you haven't created your username yet, you have to create one. This Hayden McNeil site is a different site than our Blackboard. It's run by the actual book company. So you need a separate login for that. And if you haven't purchased the online labs yet, you will have to purchase that separately. Now, there are going to be things on my page that look different than yours, hidden from students. You can't see those, I can. But what we're going to do today is we're going to do 3 labs. We're going to do Introduction to Lab Simulations. We're going to do Laboratory Skills. And we're going to do Molecular Mass by Freezing Point Depression. So I'm going to start with Introduction to Lab Simulations. So to start the lab, you click on this first link here. And you have your background here. I strongly recommend you read all of this. And when you have read all of this, you want to click this arrow down here to continue. And again, we have our some things to read. And then to run the experiment, click on this box. Click on Start Lab. What do I need? I need all this stuff. Enter lab. And you'll be taken to the simulation. Now, when doing simulations, if we go back to our previous tab, this will have our protocol in it. So you need both tabs at the same time. You need the simulation tab and you need the protocol tab as well. So you can switch back and forth. So let me just do the first couple steps of this protocol so there's no confusion. So on the lab wall, there's 3 shelves. And there's an arrow on either side of the shelf that you can click to scroll through the content. So click and drag the 150 milliliter Erlenmeyer flask. So this, when you highlight stuff, it'll tell you what it is. So I need the 150 milliliter Erlenmeyer, put it on my lab bench. Then get 6 molar hydrochloric acid, use the material shelf to get additional material. So I go to material shelf and I look for this 6 molar acid. And it's not any of these, so I need to click the arrow, move over a little bit. 1 molar, 6 molar. So here it is. And I have to see what to do with it. So add 50 milliliters. 50, add, and it fills right up. So go through all these steps and make sure when it says record stuff, that you do record. Like step 8, record the maximum temperature. And there's different experiments for this beginning. So experiment 1, 2, and 3. And then when you're done with that, you can go back to our landing page. So you can just click on Chem 112 Lab Sim Summer 2021 Andrews. And for this lab, in every lab, you can see there's 2 tabs, short answer and multiple choice. So click on the short answer. And you can see there are different experiments here that are different short answers that you need to answer. This is one way I'll grade you. And then if we go back, there's also multiple choice that you need to answer. And I'll be grading that as well. These are fairly easy if you do the lab. So nothing too much to worry about. So we're going to do that for lab simulations. We're going to do that for laboratory skills and molecular mass by freezing point depression. Now, I just want to talk a little bit about the theory behind this lab. And in this lab, and we're going to do a similar lab to this in person next week, we're looking at what are called colligative properties. So you might have learned this in lecture already, but colligative properties are properties that are change of a liquid when you dissolve a solid in it, right? So freezing point lowers, boiling point increases, vapor pressure decreases, and osmotic pressure increases when you dissolve a substance in a liquid. And the thing about colligative properties is it doesn't matter what you dissolve. All that matters is how much you dissolve. And we're going to look at freezing point in this lab. And our freezing point equation is given here. So the change in freezing point, so delta, whenever you see delta, that means change. And in science, it's always going to be your final condition minus your initial condition. So the freezing point at the final point of this experiment minus what our initial freezing point was is equal to I. I is called the Van Hoff factor. What I is, it's how many particles our substance dissolves into. So if we look at a salt like sodium chloride, when we dissolve that in water, it becomes a cation sodium and the anion chloride, right? They separate from each other. So this one particle becomes two particles. So the Van Hoff factor for sodium chloride is 2. While something like glucose does not break apart in water because glucose only has covalent bonds. So hopefully you remember that. If a molecule contains only covalent bonds, that is, if a molecule is made out of non-metal atoms only, it will likely not break apart in water. Your exceptions being acids and bases. And since it does not break apart in water, it has a Van Hoff factor of 1. Sodium chloride is made from a metal and a non-metal. This has ionic bonds. Ionic bonds do break up in water. That's why you get a Van Hoff factor of 2. Then we have Kf. Kf is just a constant that will be given in experiments, and Kf for water is here. And last, we have molality. Not to be confused with molarity, it's molality. And molality is the amount of number of moles of solute, so N means moles, divided by the solvent mass of solvent. So moles of solute, remember the solute is what you're dissolving. Divided by weight or mass of solvent and kilograms, that's important. And so your solvent would be like water in this case. So that's one thing we're doing, looking at freezing point depression. We're also looking at determining the molar mass of a substance, of an unknown. And you can determine the molar mass of an unknown if you measure the freezing point of your solution. So molar mass, hopefully you remember this from Gen Chem 1, is mass of solutes divided by the moles of solute. So molar mass is always the units of grams per mole. We can then combine this with our molality equation as shown to see that molality equals moles of solute in grams divided by molecular mass times mass of solvent. Doing some algebra, we can see that the molecular mass of an unknown, which we're trying to find, is equal to the mass of our solute divided by molality times moles of solvent. So a little bit confusing equation there, not something that's used all that often, but hopefully with this page open, you can follow along with this algebra. If not, I will, of course, be there to help you. And so this lab will walk through, freezing points, how to measure the freezing point using a cooling curve, and you'll answer questions about colligative properties and figuring out the mass of unknowns. If you have any questions while doing these simulations, don't hesitate to reach out. Other than that, I don't have much for you. So I'll be here from 11 to 3 on Zoom if you have questions. Otherwise, I will see you in person next week. Have a good lab, everybody.